Hello everyone, my name is Abhiraj Chouhan and I am from MTech-IT fifth semester, and in today's video we will be solving end semester question paper of data science. So let's begin. Question number 1A part. Distinguish between hypothesis driven and data driven paradigms in data science. Provide an example of each. Coming to hypothesis driven analysis. Hypothesis-driven analysis follows a traditional specific approach where the analyst starts with a predefined hypothesis and then collects and tests data to confirm or reject it. This process is guided by theory or prior expectations. Example, a policing analyst hypothesis that cases with no witness takes longer to resolve and test using this complaint resolution data. Meanwhile, data-driven analysis does not begin with a fixed hypothesis. Instead, patterns and insight emerge directly from the data using exploratory analysis or machine learning methods. It allows unexpected structures, correlations, or clusters to surface without prior assumptions. Example, using clustering on large complaint logs to discover previously unknown grouping of offenses or emerging hotspots without any prior theory. Hypothesis-driven analysis starts with a predefined assumption and tests it using data, while the data-driven analysis lets pattern emerge directly from the data without prior expectations. A data-driven example, where cases without witnesses take longer to resolve. Coming to the B part of the question number one, differentiate between structured, unstructured, quantitative, and categorical data with suitable real-world example. Structured data refers to information that is organized into fixed fields, rows, and columns, making it easy to store, research, and analyze using databases. It has well-defined schema and strict formatting rules. Real-world examples. Real-world example is a police complaint register stored in SQL table containing attributes like FIR number, date of incident, accused age, offense section, and police station ID. Structured data does not follow a predefined data model and it is often free form, irregular, or multimedia in nature. It requires specialized processing techniques such as NLP or computer vision. A real world example is narrative text of complaints, body worn camera footage, scanned written statements, audio recordings of district call, or social media screenshot attached to cases. Quantitative data include numerical values that represent measurable quantities. Such data supports arithmetic operation and statistical computations. It may be continuous or discrete. Real-world example incident duration in minutes, estimated final loss, number of accused person, evidence strength, scores, or count of exhibits seized. Now coming to categorical data, it represent labels, group, or qualitative qualitative classes measure it cannot be meaningfully used for arithmetic operations or classification and grouping. Real world example is offense category example theft, assault, jurisdiction, or male, female, height, or any color. Question number two, question number 2A part. Write an algorithm that utilizes Bayes' theorem for decision making. Naive Bayes is a probabilistic classification algorithm that applies Bayes' theorem with the assumption that features are conditionally independent given the class. It is used for decision making by choosing the class with the highest posterior probability. This here is the algorithm. In by first we take a input. In input we take a set of classes C1, C2, and C1, C2, CK training data. Now after that training data for estimating priors PCI features like likelihood, a new case x is equals to x1, x2 going to xn steps of this algorithm are compute prior probability of each class Ci from training data, compute likelihood for each feature xj under each class Ci. Apply Bayes theorem, compute the posterior score for each class. Here is the formula for posterior score. Normalization not required for comparison. Choose the class with the highest posterior score. Output the predicted class and probability. Question number 2B part. Write any suitable algorithm for associating rule mining that can print all association rules. For this, we have chosen a priori for association rule mining algorithm. In this, we first take input. For input, we take transaction database, minimum support, and minimum confidence, and um, our output is all association rules that satisfy min-sub and min-con. Steps of this algorithm are: step 1, find all frequent item sets, then scan the database to find support of each item. Keep items whose support is greater than or equal to min sub. Call this L1 frequent one item sets. For K2, K3, Kn repeat. Uh, then 4, generate candidates K item sets by joining frequent K1 items. This is called a priori join. Scan the database and count support for each candidate in CK. Then keep only those candidates whose support is greater than or equal to min sub. This becomes LK. Then seventh step, stop when no frequent item sets are found. All frequent set items are equal to N1 union N2 union L3. Step 2, generate association rules from frequent item set. For each frequent item set F with size greater than 2 for for every non-empty subset A or F, let B is equals to F minus A. Compute confidence is equal to support A. Then for every non-empty subset of A, let B is equals to F minus A. Compute confidence is equal to support F upon support A. If confidence is equal to or equal is greater than or equal to min-conf, output rule says that A to B with it supports F and confidence. This procedure prints all the association rules that meet both both rule for mining. Coming to question number 3a, compute mean, median, and mode and standard deviation for a given small dataset. Explain when each measure is appropriate. For the dataset, we'll take the marks. We'll take this marks of 8 students in an internal test. These are the marks. First, we'll calculate mean. Mean is equal to sum of all marks divided by number of students. Total. So the total of this is equal to 510. Then mean will be divided by 8. Then mean will be 63.75. The mean tells us the overall average performance of the class. It is useful when marks are fairly balanced, but it can be pulled upward or downward by extreme scores like 90 here. Median means the middle value. Since there are 8 values, median is equals to average of fourth and fifth values in sorted order. Sorted order will be 42, 55, 55, 60, 63, 70, 25, 90, which is from smaller to the greatest. Then after taking these two middle values and divided by 2, we've got the 61.5. The median represents the typical student performance. Outliers, even if one student score extremely high or low. What is the difference between errors and artifacts in data cleaning? Explain any two imputation techniques. Error in data cleaning refers to incorrect or false values that arise from mistakes in entry, recording, or measurements. Example include wrong dates, impossible ages, or mistyped numbers. These values does not reflect the true real-world information. And artifacts, on the other hand, are distortions or anomalies introduced by the data collection or processing system itself. They are not wrong in the sense of human error, but are byproducts of sensors, OCR tools, extraction pipelines, or formatting rules. For example, repeated tokens from text extraction, duplicated entries created by syncing systems, or missing fields caused by template changes. The two imputation techniques are mean median imputation and class specific imputation. Class specific imputation, missing values are filled using statistics computed when with mean median imputation is missing numerical values that are replaced with mean or median of the existing data. Mean is suitable for roughly symmetric data, whereas median is preferred when the data has outliers. Class specific imputation, missing values are filled using statistics computed within each class or category. For example, missing marks for student in a particular section can be replaced using the section's mean rather than the overall mean. This improves accuracy when different groups have different distributions. Coming to the question number four, explain any four common feature engineered techniques for continuous or categorical data. Feature engineering transforms raw data into more useful inputs for analysis or machine learning models. Four common techniques are as follows: normalization, scaling, continuous features such as age, income, or severity scores are rescaled using methods like minimum to maximum scaling or z-score standardization. This prevents large valued attributes from dominating models and improves convergence in distance-based methods. Binding and discretization. Continuous variables are converted into categorical intervals. For example, complaint severity scores may be grouped into low, medium, and high. Binding reduces noise, handles outliers more robustly, and allow algorithm work better with categories. Third one is one hot encoding for categorical data. Categorical attributes such as jurisdiction or offense types are converted into binary indicator variables. Each category becomes a separate column with values 0 or 1, enabling algorithms to work with non-numeric neighbors without imposing an artificial numeric order. Fourth is feature extraction and transformation. Example PCA, IDF. Complex or higher dimensional data is transformed into more informative format, converts narrative text into weighted term vectors. For example, PC reduces dimensions by creating new uncorrelated features that capture variance. Coming to the question number five, distinguish between parametric and non-parametric models and supervised versus non-supervised learning with examples. Parametric models are models which assume a fixed functional form and predetermined number of parameters. They learn only those parameters from data. These models are simplest, fast, and work well when the assumption fits the data. Example, linear regression, logistic regression, and Bayes theorem. Meanwhile, non-parametric models make no strong assumption about the data functional form and can grow in complexity as more data becomes available. They are more flexible but are computationally heavier. Example, k nearest neighbor, which is called KNN decision trees, random forest, etc. Then supervised learning and unsupervised learning. Supervised learning uses labeled data where each input has known target output. The model learns to predict the output for new unseen inputs. Example, classifying into offense types, predicting severity scores from feature. Unsupervised learning uses unlabeled data to discover pattern structure or groups without predefined targets. Example, clustering complaints into thematic category, detecting unusual cases through anomaly detection. Question number 5, B part, define accuracy, precision, recall, F1 goal. Illustrate their computation using a confusion matrix. Accuracy measures the overall correctness of a classifier. It is the proportion of all predictions that are correct, both true positives and true negatives. It is useful when classes are balanced. The formula for accuracy is TP plus TN plus TP divided by TP TN plus FP plus FN. It, in our data set, we have taken this data set which is predicted negative and predicted positive and actual positive and actual negative. In our data set, when we apply this formula, the accuracy comes out to 0.85. Precision, precision measures how many of the instances predicted as positive are actually positive. It focuses on the quality of positive predictions, and it is important in applications where false positives are costly. The formula for precision is upon TP plus FP. If we take our data set, the precision comes out to be 0.888. Question number 6, A part, define how coefficient in linear regressions are estimated using either the closed form equation or gradient descent. In linear regression, the goal is to estimate coefficient weights that best fit a line or a hyperplane to the data. The coefficients are chosen so that the sum of squared errors between predictive and actual value is minimized. Closed form solution Normally, the coefficient can be computed directly using the formula, which is this: beta is equals to x to the power t x to the whole power minus 1 and x to the power t y. Here x is the design matrix of input features and y is the output vector. This solution gives the exact least square estimate in one step, but it becomes computationally expensive when the number of features is very large. Coming to the gradient descent is an iterative method that starts with random coefficient and gradually improves them by moving in the direction that decreases the error. For each update, the rule is this formula: beta is equals to beta minus alpha, alpha upon alpha minus alpha beta MSE, where alpha is the learning rate. Iteration continue until the error converges. Gradient descent is preferred for large data sets or high dimensional problems because it avoids matrix inversion and scales efficiently. In summary, the closed form method is exact but expensive for large data, while gradient descent is approximate but scalable and widely used. Question number 6. B part: explain logistic regression and logistic function to calculate the probability of a class or for a given input example. Explain logistic regression is a classification method that predicts the probability of an input belonging to a particular class, usually which is the positive class. Instead of fitting a straight line, it uses the logistic sigmoid function to squash the output into a value between 0 and 1. The model learns coefficients that define a linear combination of features, and logistic function convert that value into probability. Logistic function is P class is equals to 1 mod x is equals to 1 upon 1 plus e to the power minus z, where z is equals to beta o plus beta x1 plus beta 2 x2 continues to be x1 m. Calculating probability. Suppose the model parameters are beta 0 is equals to minus 2, beta 1 is equals to 0.005. For a student with marks 70, the linear score is comes out to be 1.5. Applying the logistic functions, which is this formula, becomes out to be this answer. The logistic regression model predicts the probability that the input belongs to. So that's it. Thank you for watching. In this video, we have solved the end semester question paper of M.Tech IT 5th semester subject data science.